Section 4.5, the intermediate value theorem. Consider the following two problems. Number 1, prove the existence of a real number whose square is 2. And number 2, assuming the temperature varies continuously over space, prove that, at any given time, there are 2 points on the Earth's equator directly opposite one another that have the same temperature. You believe that second one? It's a little bit surprising, I think. Well, despite the fact that these two questions sound kind of different, they can both be solved using the intermediate value theorem, which you probably heard for the first time in your Calc 1 class. Here's what it says. If you have a continuous function, f, from the closed and bounded interval from a to b to the real numbers, and if L is a real number between f of a and f of b, then there exists some c between a and b, such that f of c equals L. Now, there may well be more than one such c that works, but the theorem is saying that there's at least one such c. Okay, so let's try and illustrate the theorem. Draw our axes, and we have the domain from a to b. Let's try and draw a function with that domain. Maybe something like this. Okay. And so for this function, f of a is about here, and f of b is up here. And for L, we could pick anything in between f of a and f of b. So maybe L could be right about here. And then we're interested in places where the function has the value L. So draw a little dotted line here. And it looks like actually there are 3 different values between a and b where this function happens to have the value L. One of them would be right here, for example. So there's one c, which satisfies the conclusion of the theorem. Okay. So we're going to prove this theorem later on in the section, but before that, how about we use it to go back and try and solve these 2 problems that I stated at the beginning. So the first problem was prove the existence of a real number whose square is 2. All right. Well, we need to recast this problem somehow so that it has to do with a continuous function. So here's how to do it. Notice that we are looking for a 0, or root, of the function f of x equals x squared minus 2. Right, because if x squared minus 2 is 0, that means x squared equals 2. Now, if we're looking for a 0 of the function, then we need to find somewhere where it's positive and somewhere where it's negative. And we think the square root of 2 is somewhere between 1 and 2, so how about we take f of 1, which is negative 1, and f of 2, which is 4 minus 2 is 2. Okay. Well then, since f of 1 is less than 0, and f of 2 is greater than 0, well, say by the intermediate value theorem, which we can apply because our function f here is certainly continuous, there exists some c in between 1 and 2 such that f of c is equal to 0. And f of c, if you look at the definition of f, is just c squared minus 2. So that's 0. Or in other words, c squared equals 2. So we're done. We have found a real number c whose square is equal to 2.